So now our first problem is a division. Does anybody remember this from last year? Anybody remember the division thing? How we handle the division? Well, there is a rule that you can't have an I on the bottom. So this problem is not good. It has an I on the bottom. Mission accomplished. Okay, you ready? So to get rid of the I on the bottom, we are going to multiply both the top and the bottom by what we call the conjugate of the bottom. The conjugate of 6 minus I is 6 plus I. You remember that? We change the middle sign. So if it had been positive, to start with, I would make it negative. I change the middle sign. And I'm going to multiply the top and the bottom by the conjugate of the bottom. So now it just becomes 2 giant FOIL problems. Would you agree with that? So we're going to start FOILing. First, outside, inside, and last. And remember, when you multiply an I times an I, just like everything else, you're going to get I squared. Okay? Now, before we clean that up, which we're going to have to do, let's go ahead and FOIL out the bottom. Okay? So what happens on the bottom? FOIL again. So we have first times first, outsides, insides, and last. All right, everybody good so far? This is a big problem. Now we're going to clean it up. So I want you to look at the numerator. Nothing cancels. Don't you dare start doing any of this stuff. No, 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 no. Let's look at the top. Can we add these two together? Yes. Aren't they both like terms? They're I's. So we have 30 plus, what is that, 23I? Now wait a minute. What did we say the other day about I squared? What does I squared equal? -1. So if you haven't already written that down, please write it down. Every time you have an I squared, what you really have is a -1. So this is 3 times -1, which is -3. All right, what about the bottom? What happens to these guys? They cancel. That's why we did it. Because now on the bottom we have our 36, and then what do we have here? +1. So remember what Kate said? You can't have an I on the bottom. Do I have an I on the bottom anymore? No. On the bottom now I have a 37. Now what about the top? Is there anything else I can do to clean up that top? I can do these two, right? So that gives me what? 27 plus 23I. And that is the answer to the question. So if we have an I in the denominator, we are going to multiply top and bottom by the conjugate of the bottom. And then it just becomes FOIL, 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 simplify, simplify, simplify. Okay? And in the end, you're still going to have an I in your problem, but it's always going to be just on the top, which is okay. All right, how about this guy? Okay, well, how am I going to handle that? We kind of talked about this yesterday, but kind of in an accidental way. It came up in a problem. What did we say we did when we had a negative under the radical? Why?
Separate it, so you have I times radical.
Exactly. So anytime you have a negative under the radical, you're going to say the square root of a negative is I. So I'm like pulling that negative out, but when I pull it out, it becomes an I. And I still have the root 81 left, and of course, what is root 81? 9. So my answer is just 9i. Now here we're going to do exactly the same thing, one at a time. So forget this, do that. What am I going to do first with that? Pull out the I. And pull out the I. That's step one. If you have a negative under a radical, don't do anything until you pull it out. Okay, then do whatever you need to do. Okay, what about this? What's the square root of 4? So isn't this 2i? Times, what's this? 3i. Perfect. Now I'm going to times those together because that's what's happening in this problem. It's a multiplication problem. So I'm multiplying together, and what am I going to get? 6i squared. But wait a minute. What's I squared? Negative 1. So my answer eventually ends up being negative 6. All right, everybody good? All right, let's look at this next one. This next one is super simple, but it looks super hard. Do not be afraid. Do not be afraid. This is about the easiest problem you could ever have. You want to take a wild guess? What do you think X and Y are? That's your job. What's X? What's Y?
3.
Who said that? Very good. 3 and 2. Kids, look. If 3 plus 2i has to be the same as something plus something I, then doesn't it make sense that this number has to be a 3 and this number has to be a 2? Isn't that how they're going to equal? I mean, it wouldn't make any sense to say 3 plus 2i equals 7 plus 5i. That doesn't make any sense, right? If they're going to be equal, these two have to match, and these two have to match. So in this case, if these two have to match, X has to be 3, and Y has to be 2. Okay, that's how easy it is. So we look at the next one. Do not get blown away. Do not be afraid. Okay, here we go. Now look at it. Notice that this guy and this guy are standalone numbers. They do not have an I. This guy and this guy are not standalone numbers because they do have an I. Does it make sense to you that the blues have to be equal and the purples have to be equal? The standalone numbers are equal, the I numbers are equal. So what's my answer? 3 is X, or X is 3. And negative Y is 7, so Y must be negative 7. There we go. It's that easy. The standalone numbers match up, and the I numbers match up. Okay. All right, now we have a couple, actually we now have 4 kind of review problems. So we're going to solve problem 3A. There's nothing new here. We've done this. How could we solve, it doesn't tell me how could I solve this problem? I want you to look at it carefully, think about it. It's a quadratic, x squared. What are some options that we have? Jade, I heard I'm reading lips, she says factor. Is factoring always an option? Well, it's an option, but will it always work? And I don't think it's going to work this time, Jade, because can you kind of see why? this is gonna have to be a 2 and a 2, or 2 and a 1, right? Would you agree with that? And there's no way that a 2 and a 1 is gonna give me a 4. So this one doesn't factor. Factoring is an option. Okay, keep it on the table, but it doesn't work all the time. So what else do we have as options, Daryl? We can always use the quadratic formula. And if we use the quadratic formula, our A is 1, our B is, and our C is, okay, that's the quadratic formula. Here we go. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, I'm ancient. I do this for a living. The quadratic formula is boom, boom, boom for me. You might need to write it down. You could write it at the top of your paper to help you. All right, so once we get that all written out, then now I'm gonna start simplifying. So what have I got underneath here? I have 16 minus 8. And what is 16 minus 8? 8. Now, at this point, gang, some of you are going to be tempted to try to cancel. Please don't, because you can never cancel numbers under a radical, and you can never cancel in an expression like this that has 3 parts unless you can cancel all 3 parts. So if you try to cancel here, wrong. You have to do all 3 parts. We call it the triangle of canceling. What could I do though? There's no canceling at this point, but what is there to do? Reduce or simplify the square root of 8. So what's the square root of 8? Well, 8 is 4 and 2. So 2 comes out, 2 stays in. Now look. Now I can cancel. You see it? Now I can cancel here, and here, and here. Those are the 3 spots that if you're gonna cancel, that's where you cancel. So, 2 goes into here, negative 2 into your 1s into your 1. So it looks like my answer is negative 2 plus or minus root 2. Negative 2 plus or minus, you can put a 1 root 2 over 1. Did anybody, that's fine, that's perfect, beautiful. Did anybody think about another option though? Another way to do this problem if you wanted to?
I started doing the completing the square, but I got confused once I got to after the first couple steps.
Okay, so she wanted to complete the square, and honestly, this is an easy problem to complete the square on. I am not a big completing the square person. I mean, if I found a problem in the hallway, I'm probably not going to complete the square. I'm probably going to use the formula. But this would be an easy one, Mackenzie. You're right. I'm going to move the 2 over. Half of 4 is 2, and 2 squared, remember we have to square it, is 4. So I'm going to add 4 to both sides.
Oh, yeah.
This guy will always be a square. What square will that be? X plus 2? So x plus 2 equals plus or minus root 2. Look what happens when I move that 2 over. Do I get negative 2 plus or minus root 2? Which is exactly what I got with the Yeah, exactly what I got with the formula. And you don't have to do it both ways, guys. I did it both ways, one way is good. So, having said that, Kate,
On the quiz, are you gonna have a problem with each way, or
Yep.
are we gonna
Yep.
do it
No.
each way?
you need to know the method. So there will be a problem that says solve by completing the square. There'll be a problem that says solve the quadratic formula. And then any other problems, you can do any way you want, but you do have to know both methods.
This second method is called completing the square,
This
right?
is called completing the square.
And will we have to know the factoring method?
You do not need to know the factoring method for this, I don't think. I'll have to double check, but I don't think for this unit we do. You have to do it that way. There are times when it's easier to do it that way, but you don't have to. All right, so here we go. 2x squared minus 9x plus 7. Work it out right now, one way or the other, however you want to do this. Maybe it factors, maybe it completes the square, maybe quadratic formula, whatever you want. Let's give it a shot and see how we do. What you're doing here is anybody, well, what are you doing? How are you doing this? Everybody's busy working, that's awesome. Quadratic formula. Everybody's formula? Everybody did the formula. Okay, well, I am with you 100% about not completing the square. Because remember, completing the square requires you to divide by 2. Yucky. Fraction, yucky. Don't want to do that, right? So we are, I guess the formula is great. Let's give it a shot and see what happens. Keep going. If you're still working, I'll do it too since I know what you're doing now.
So what stuff, can we just like do quadratic formula every single time, or do you not?
The quadratic formula will always work. It never lets you down.
Do you recommend that though?
It's what I do. But, like she said, you have to know how to complete the square. So you are gonna have a test question that says you must complete the square. But if you're left on your own, like we're doing random problems and a quadratic pops up, you can always use the formula. Always. It isn't always the easiest way, but it will always work. Is that, I wondered why I kept seeing calculators, but we got some arithmetic going on here, don't we? Did you get 25 under there?
Yes, ma'am.
So this one, I swear 25 is 5, but I hope you didn't stop there because this one actually simplifies. So we're gonna do 9 plus 5 over 4, and we're gonna do 9 minus 5 over 4. So the actual answers that you wrote down should have been 7 over 2. And what? Now, is there anybody that didn't get that we need to talk about? Because we need to be able to use the quadratic formula. Everyone good? Now, I want to show you something. This problem actually does factor. I thought somebody might factor it. but it actually does factor. So you could have factored it if you wanted to. Would the answers come out the same? We're gonna get positive 7/2 and positive 1?
So does, completing the square, does that work every
Oh,
time?
every time. Now, completing the square works all the time. In fact, if we had time, I would show you, that's where the quadratic formula came from. If you take the standard quadratic, which is something x squared plus something x plus, okay, if I did completing the square with the letters, the answer would be the quadratic formula. So actually, in the big scheme of life, completing the square came first, and then the quadratic formula after that. When you complete the square, guys, I'm gonna try to keep away from fractions, because fractions do make it a mess. I would never in 1,000 zillion years complete the square on this, but I would get the right answer if I did. It would just be messy.
And when you complete the square, there can't be a,
No, that's what makes it messy, because you're gonna have to do this to start with. Now, you do not need to do that with the quadratic formula. A can be anything in the quadratic formula, so leave it alone. But if you were completing a square, that is what you would have to do. That's why I do not want to do it. Okay. Got a couple more review problems here, guys, right here. What are we gonna do? You ought to be able to do this. We talked about this one last time, and we talked about it a little bit in another problem today. What are we gonna do? Foil. This is a foil. So first, outside, inside, last. Remember, FOIL, just like you've done since you were little. You're foiling. Okay, now what? I can add the middle two for sure. These two add, what does that make? Negative 13. And what about that last term? Negative 14I squared. Positive 14? Because I squared is negative 1. Every time I see an I squared, it's negative 1. Right? And if you haven't written that down yet, I told you earlier, get it written down. So this becomes plus 14. Yep. So now I've got 26 minus 13I. And I'm done. That's it. That's my answer. Okay. All right. Now, B, we did one, very first problem we did today. So I'm going to get you started, but I want you to do the work here, see how far you can get with your partner. We have 5 plus 7I over 3 minus 2I. Now, first of all, what's wrong with this problem?
You have the eye on the
You have
bottom.
an I on the bottom. Okay? Anybody remember how we get rid of the I on the bottom? Conjugate, which is what? What would it be in this problem?
3 plus 2i.
Yep, we're gonna multiply top and bottom by 3 plus 2I. Remember, when you, with the thing you multiply by, called the conjugate, you change the middle sign. So whatever you got, you just make that the opposite of what it was. Okay, and then what do? Foil. All right, start foiling. Let's go. We're gonna foil, foil, foil. Bunch of foils. First, outside, inside, last. Already done, Jared?
Yeah.
Tell me what what you got. What's your final answer? Let's see if you get up there.
1 plus 31 over 13.
Over 13? I don't know if that's right, guys. Might be right. Jared said it was right. That's probably right. But you agree? So we have 2 votes for this. Another vote for that? Alright. Phoebe, foil the top for me. What do I have when I foil the top there?
5 times 3 is 15.
Yep.
And then 5 times 2 is 10i.
Yep.
And then 7 times 3 is 21i. And then plus 14i squared.
Beautiful, beautiful. Now, Phoebe, you wanna go ahead and simplify that for me a little bit? What did you do here to clean that up?
I added 10 and 21i.
So you got that 31i.
Yeah, and then I changed the 14i squared to negative 14.
That becomes a negative 14.
And then I added 15 and negative 14.
So far, Jared looks like he's right on target, right? Okay. Who's back there in the back? Izzy, can you foil the bottom for me?
You have
No, you're right.
you have
Nine.
9 and then 6
Mhm.
and then another 6.
Actually, that one though is gonna be minus, because it's negative 2 times 3. That's gonna be minus 6i, okay? And then what do we have here? It's gonna be negative 4
Oh, I squared.
I squared. Is that okay? Now, the reason we did what we did was so these would cancel, because I don't want to have any i's in my denominator, and they did cancel. And what happens to a negative 4 I squared? Positive 4. And there's your 9 and 4. Jared was exact, and all the rest of you agreed were exactly right. Got it? Got it? Okay, P6 is due on Friday. And now we're gonna go ahead and, do some inequalities.
I'm gonna text you. I'm gonna go before and after.
Alright, so here we go. We're gonna solve this problem. Now, you had an inequality on your quiz, but it didn't have absolute value in it. So this is a little different now. It's got absolute value in it. So, you may have any remembrance, any memory of doing this last year? Do you remember how you did it last year? Go ahead, Jack.
Something like related to between the brackets and changes to
Okay, when you take the absolute value of something, it will become positive. But when it's a quantity like that, you don't mess with that, okay? So if it were just this, if you had this, that would be 2. Yeah, that would be 2. Do you remember how you did these? No? Oh, now you're putting me in a bad spot because if you remembered how to do it from second year algebra, I would do it that way. I would rather do it the calculus way, but you've never done that before. So we'll go ahead and do it the way you did it last year and hope that you remember this. I don't like this way, but it's how you did it. So x minus 2 greater than 3, we just drop the absolute value. Just drop it. And then we rewrite it, because we're gonna get two things here. There's 2 things. So then I rewrite it, x minus 2 less than -3. Now is it coming back to you? I hate these, me too, that's why I don't like doing them this way. So x minus 2 is greater than 3, or x minus 2 is less than -3. Now, do you remember that sometimes we use or and sometimes we use and? Do you remember which is which? What symbol is this? That's a greater. Say the word, greater. When it's a greater, you use or. Okay, now I know that sounds dumb, but somehow you have to remember this, okay? If it's a less than, then we'll use an and. Less than and. They kind of sound the same too. So,
When it's set up like that, we always
whenever it's an absolute value problem, you're gonna get two answers. You're gonna get two, so you break it up into two parts.
So if it was less than.
Okay, we'll do one of those, Kate. Just hang on and get this down, okay? Get this one down, and then we'll go on. So this problem, I copy it exactly for part 1, and then I change this sign and make that negative for part 2. Then I solve each one of these. So I add 2, and this is what I come up with as my answer so far. Now what does that look on the number line? Well, here's 5, here's -1. It says I have to be less than -1, and I have to be greater than 5. So my answer, here's -infinity, here's +infinity. My answer is this interval, -infinity to -1, or, and that's the mathematical symbol for or, it's called the union symbol, or this interval, 5 to 4. That's the answer to the problem. So I have an absolute value. Gotta break it apart into 2. It becomes 2 problems. The first problem is just copied exactly. Don't change a thing. Just leave these out. Just copy it exactly. The second problem, the sign switches, the direction of it switches, so it's going greater than, and this is gonna be a -6. Those are my 2 parts. First one copied exactly. Second one, flipping this and making that negative.
So we'll always have 2 points.
And the key word in between is and, because less than is an and. Greater is an or. And it's gonna make a difference. You'll see here in a second. So then I solve each piece. So I'm subtracting 5 from just solving each one of these individually. This is what I come up with. So I've got -11, greater than that, 1, and I'm less than that. Means it has to be this and this, it's gotta be both. What numbers are both? All the ones in the middle. So this time, little space. Just that space, no infinities involved, it's this space. So it's bracket -11, bracket 1. That's the answer. When it's a great or, it was an or, so I was kind of looking at all this out here. When it's a less than, it's an and I'm looking at this and this, so it's the overlap. Okay. One more, and then we'll call it quits for the day. Then break this apart into two inequalities. What's your first one? What's part 1 gonna be for this problem? 2x minus a is greater than or equal to 7, period. Don't change a thing. What's the second part? 2x minus a less than or equal to -7. What's the key word that goes in between? This is a greater, so the word in between is going to be or. Here we go. Let's add 8, divide by 2, add 8, divide by 2. Do my numbers match yours? So I'm gonna look at it on the number line. Here's a half. And here's 15 halves. I need to be less than a half, greater than 15 halves. So it's either this or it's this. So negative infinity out here, positive infinity out here, here we go. What are my intervals? Negative infinity to a half, parentheses, bracket,